Requirement Specification, or as you call it as SRS. SRS is a requirements file. From the name you will come to know, or from the name you are getting to know, that Software Requirement Specification. So we'll start with what will be the outcome after running this. So what are the outcomes for today is: remember, understand, analyze, apply, and create. First is we'll define SRS and state its purpose, then understand, then judge what kind of requirement statement is good and bad. Then there is something called as IEEE standard, or IEEE specifically, if you say IEEE 830 characteristics. Then map real project content, that we'll do later as the practicum. And then we'll draft a short requirement system for our use cases that will be given to each one of you. Okay, so why these topics matter, that is the most important question we have to ask ourselves. Why do you need to make an SRS? So as you know, before you start with the project, you need to know so many requirements that is needed by a customer. Basically, when you develop something as an entrepreneur, you should always think as a like selling your product to the customer. So a customer will have different kind of requirements. You need to note it down, you need to create properly, and also managing it. So as you know, in SDLC there are how many steps? There are 6 steps. The first step is planning out. So SRS is the first step in which we'll plan out. In SRS we'll have the planning. It does We have the key term called SRS is System Requirement Specification, but it's not writing all the specifics. It's writing the overall what is the customer requirements will go, as we'll see. We'll go through that. Okay, so then next, when everyone understood wasn't enough. So what do you mean by that? As I have shown the tree example, the customer wanted something, the way he or she explained it to the student, or sorry, to the uh, to the entrepreneur or to the company is different, and how the different people in the company understood it was different, right? So the term when everyone understood wasn't enough is not enough, because everyone has different understanding. There should be a proper documentation, writing down the notes in proper way, so that everyone will understand what is there, right? Then the automated baggage system that was never left the ground. Okay, we'll have an example here. A major US airport once tried to build a fully automated airport-wide baggage handling system on an extremely ambitious timeline. Stakeholders agreed on a vision in conversation, but the system's scope, specific physical constraint, and failure handling behavior were never pinned down in the reviewable specification. The airport's opening was delayed by well over a year, and the automated system was eventually scaled back dramatically, a case now taught worldwide as a caution about keeping rigorous requirement work. So they have a very big ambition to make something automating the baggage system, but they didn't do proper requirement analysis. That is writing the SRS. So what happened? The project was delayed. Nothing was working as they thought, and the stakeholders, basically the people who put money, was on hold, right? So we don't want as an entrepreneur, because it will give a bad image, and also from a company standpoint, it will make down the reputation of the company, right? Then next, what happens without a discipline SRS? We have two tables here. We can see one is without and with. Without, what we'll see here is developers and the client silently assume different things. Scope goes, so without a shared in specification, client wants something, the company makes something, then testers cannot verify because they don't know what was there in the specification. The tester has to write test cases, right? They need to understand the project, and based on that they need to write the case. They can't just like just now they got the project and they start the testing. Testers need separate time to write the test for the specific application, so that they have to do parallelly, right? Then rework multiple as misunderstanding surface. So rework, there will a lot of rework. So when you do rework, there are wastage of money, wastage of time, wastage of employment, or wastage of labor, right? Because the thing that can be done with proper SS without our SRS, it has to be done multiple times, and with that what will happen, you need to rework multiple times. With discipline SRS is we have one file. From that file, everyone in the organization can refer to it, and they can understand what is required, right? Then design, coding, and testing all trace to the same source. Yes, because the single file. Changes are visible, negotiated, and tracked. Yes, because they have to be documented, and if somebody makes some changes, they are questionable, or they can be questioned, and they can be understood why the changes had been done, and it can be conveyed to the people overall in the organization. Then disputes are resolved by reading the text, not by memory. Memory is a culprit or memory always backstab us because we remember something and something might have been done. So we can't always rely on memory. So SRS helps in that to resolve the disputes. Then the next question is, what is a software requirement specification? A specification, not a conversation, then often build around use cases include non-functional requirements. So what is a specification? Specification is what there should be the things in the project. Okay, it's not just conversation like to and fro, hello, hi, these things are not there. What is required? A written description, then often build on use cases. So what they're going to build around the build use cases, as we write, you'll understand. Then includes non-functional. So system requirements doesn't require like, okay, this I need a CPU or RAM or this software or that software. It also requires performance, how much performance you want, security. Then money is also involved, how much money has to be done, what is the timeline, lot of things, lot of factors are there in ISRS. It's a very well defined document. It's not like 1 or 2 pages, it's like hundred of pages. For big projects it goes around more than 100,000 pages also. Okay, then requirement is not equal to specification. Requirement is something, specification is something. If you see here, requirement is what the customer and supplier understands. It includes cost, delivery charge, acceptance procedures, and broader than the SRS still catches. So requirement also includes so many things. Acceptance include cost. SRS is a part of requirement, but SRS is a small part. Requirement is broader. What is specification? What is the software itself must do? Leave within the SRS document, exclude business term like cost and schedule. Sometimes SRS, I'll not say it's truly correct. Sometimes system specification will include the cost. Sometimes it doesn't include, but basically for software, we can say that it doesn't include the cost, the schedule. It just includes what the system or the software must do. Okay. Then scope of the SRS in the development cycle. There are different scopes. One is design implementation, project monitoring, verification, validation, and legal agreement. These are four key terms that are scope of SRS in development cycle. Then this is the most important thing. What is to address and what is not to address in a SRS. Then should address is what should the functionality, performance, quality, design, what will be the structure or how will be the system made or what will be the overall system that should be there, how much fast or in what kind of systems it should work, what kind of performance or what kind of external interfaces that you need, do you need a different hardware to be connected, so on and so forth. Should avoid is design and implementation detail, project management detail. So what do you mean by design and implementation? Design and implementation is like how you're going to design and where you are going to implement it. Okay, there's a two different, like if you see functionality and design are two different things. When you read it, you'll understand. Then project management detail. In project management, like how the project is handled, which team is doing the project, who is the team leader, etc., etc. Those things are not there in SRS. Then constraints beyond what stakeholders actually impose. So these constraints, like you are thinking, they have given, for example, $2 million, you have to make it with a $1 million, or this should work in this system or that system. Those things shouldn't be there. That is, we have to resolve it, but those things shouldn't be there in a SRS. Okay. The next is IEEE 830. So how you're going to write a SRS document is well documented. That is also documented. Like there is a practice of how you write. For example, in exam you should write the questions or the answers in a pattern, right? First you write first, then you go to second, third, so on and so forth. You should write it like that. If you write it some other way, it will not be. So there is a standard, right? So similarly for writing SRS, there is another standard that we call it IEEE 830. What is IEEE? IEEE is a standard. International Electrical Electronics Engineers. That is a group that makes the standard. There are different IEEE standards for different kind of use cases. For our use case, that is for writing the SRS, we have 830. Okay. In 830, what is there? A recommended practice. It's not like a law, but how you should practice. You should always proper as engineers. We should do it properly, well documented, so that in future, if somebody wants to do it, they can understand it. So there should be a recommend practice. Then what it gives you? It gives you the skeleton, introduction, overall description, and specific requirements. Then where it sits is family, one of the family of IEEE software engineering standards. So there are different standards also related to 830. You can see here software review, etc., etc. But for us, the most important is IEEE 830. Okay. Then the role of SRS. There's two roles of SRS. One is the first rule is completeness, so without excess, stay out of design's lane. So completeness, there should not be extra, but it should be complete. SRS must correctly define every software requirement, but no more than that. What should not be? It should stay out design lane. You should not discuss design verification on project management level except for genuine design constraints. Okay. Then what makes an SRS good? SRS. Okay. What makes a good SRS? One is one consistent, it should be, then it should be ranked, verifiable and modifiable and traceable. So no requirements contradicts each other, it should be consistent. Then requirements are ordered in importance or stability. So the most important answer ranked at the first, then as you move down it should be ordered like is it, then verifiable and traceable. Okay, every requirement can be followed forward into design, code and test. Then one sentence, 3 minutes. What is a sentence? The control total is taken from the last record. This single ordinary looking sentence can be honestly be read at least three different ways by three different. The control total is taken from the last record. So does last mean the record at the end of the file, the most recently added record, or the previous record processed? The sentence doesn't say. It's taken from the last record. It last can be from the last also, and it can be yesterday's also or most recently also. So it should be documented properly. So this kind of sentence should not be there. It's very bad. Ambiguity isn't about the grammar, it's about the quietly carry more than one meaning. That is ambiguity. Okay, then two more everyday ambiguities. One is all customers have the same control field, all customers share the same value in that field, every control field follows the same format, one control field is issued for all the customers. So all customers should have the same control field. After several login fails, notify IT. How many attempts is several? That is important. 3, 5, 10. Notify immediately or batch at the end of the day. So they should be immediately notified or at the end of the day. Notify about the user or about the account. So you should be notified the user or the account. These are different everyday ambiguities. Okay. From vague intent to testable requirements. So one is unclear and complete. So we'll understand two things. One is unclear also, and here another one is clear and complete. In unclear, the system shall read updates from the imaging feed. The system shall provide historical report. It doesn't give you any clear concrete answer, right? It's like ambiguous. It's like what do you call that? Is from above you are saying something that the system shall provide history. What kind of historical report? What historicals? How many? Then if you see here, the system shall input new patient scan records from the imaging feed and flag each as pending clinical review. Then the second one, the system shall generate a patient summary report covering the preceding 5 calendar years. Okay, see now it is clear and complete. It is not clear. Did you understand the difference? So okay, we'll move to the next part. So if we see here, introduction, overall description, and specification. In SRS, there are three components. One is introduction, one is overall description, and another is requirement. Introduction, you mention the purpose, scope, definitions, and reference. Then document overview. In overall, product perspective, product function, users, and constraint assumptions. The next is functional requirements, interfaces, performance, attributes, and database. We'll go through three components and we'll learn about them. So elements of SRS document, if you see here, one is purpose, project timeline, acceptance criteria, testing requirement, user documentation, data management, system architecture, non-functional requirements, and functional. So they are composing of 9 components and they all make an SRS document, and it should be there, then only you can complete one checklist. So you should see all these things are there in your SRS. Then 5 subsection in introduction, there is purpose, scope, definition, reference, and overview. We'll learn them. Then okay, we'll start with product perspective. How the software insight? So in product perspective, if you see here, in overall description, in introduction, then overall description. So in introduction we have purpose, so scope, these are all generalized. Then next is overall description, we'll have 6 subsection: perspective, function, users, constraints, and assumptions. So in product perspective, we will put system and communication interface, what other systems and acquire networks we must talk to, hardware and memory, what kind of hardware are, what is the limitations of the platform that we are using, then user and software interface, how people and other software will interact with each other. That is the product perspective. Then function is uh, what kind of function it should work. Then group logically cluster capabilities to the shape of the system first. So you should make a flow chart or something how different components of a product works together, so that a person who is seeing the image, they can understand, okay, oh this is how it is working. Okay, so that is how you should group logically. And the next is user characteristics, is what kind of users do you need to make that, or educational level and experience, what kind of experience do you need for certain things. Are users domain experts, casuals user, or complete novice? So for the product to be used, what kind of ex, people are using it, then technical expertise, how comfortable are they with technology in general, not a requirement list. This section explains why later requirement exists, it doesn't state them. It says why requirements exist, it doesn't state them, means what kind of people they will be using, what kind of technical expertise they are having, so on, and constraint. Then what kind of hardware limitations you are having, then how it going to connect, is it going to connect to Google, is it, you are going to log in with Google or something, etc, etc. As you know, for example, our college edus, if we log in using Google, right, then it can be Google, or else if it was not Google, then it should have been Microsoft. I'm giving an example. So what kind of interface they should be having. Okay, then reliability, safety, and security. What kind of safety? This is the most important, because reliability, safety, and security is the three components that make us software good. Because if your software is not reliable, not safe, and not secure enough, this is one of the most important key areas that need to be fixed when you are making a product. Because if it is a very sensitive, for example, our Aadhaar card application, if it was not secure properly, what will happen, our information would have been leaked, and people would have gone our Aadhaar card, they can use our Aadhaar card to forge our user's ID, and they can do all kind of notorious things. Okay, then assumption, dependency, and appropriationing. Okay, so assumptions and dependencies, what kind of external factors we need to, what kind of things that is there. Then for example, here needing a language editor for future translations, that means in future we need a language. For example, in a system there will be different languages that you can switch to, though that is one assumption or dependency. Then what kind of requirements, identifies requirements that may wait for future release, so we will be releasing different updates, right, so we will have that thing also. Then keep version of scope honest and shippable, prevent silent scope creep into the current release. So everything which should be released in the scope version 1 should be there documented. You cannot creep, means you cannot insert any other requirements that is not there mentioned. You can release it the next version of scope, but it should be mentioned before releasing it. Okay, then 16 requirements, that is the heart of SRS. So this is the most important thing. Sufficient detail to design, sufficient detail to test, organized, not just listed. So everything should be organized properly, sufficient details so that it can be tested, and sufficient details so that it can be designed. Then functional requirements is shall statement. Function requirements are written in testable shall. The system shall reject a submitted from. So what kind of requirements are there? Then input, processing, output. Each requirement should trace a clear path. So this should be the input, this should be the processing, and this should be the output. For example, image. So I'll insert the image of an MRI. It should be the image of an MRI of a boy, for example, only boy only. You should process the image, and the output should be the what is the outcome or LLM has thought about the image. That is the output. This is a very basic, or what do you call it, you are not writing it like this. For different requirements, it will be, the requirement will be different, so you should write like this: the system shall reject a submitted from when any mandatory field is empty, and shall display which field is missing. For example, when you're logging in, right? And then external interface requirements, so different, what kind of APIs, libraries, ports, protocols, what kind of screen, is it a touch screen in like for example, for touch screen you need to make it somewhat different, or is it like only web based, or is it going to be ported, or is it going to a web application or a mobile application, so on and so forth. Okay, what kind of is it going to TCP, UDP, is it the gaming application, etc, etc. Okay, then performance, design constraints, what kind of performance should be there, what will be the design hardware limitations for performance, how many users can use it, or what should be the fast, how fast should be the outcome, is it, can you make it a slow, or it should be very fast, depends on the use case. Okay, then software system attributes, reliability, security, this I've already mentioned, right? So modeling the requirements, you should have data flow diagrams, data or ER modeling, how the model attributes for this is for database. Then state transition mod diagrams you have learned in math. So state transition is if I click on the password wrong, then it should move back and should show me that password is wrong. If I have not filled any field, it should show that please fill the field. If I have put the correct password, it should move to the next, that is the home page. So these are different state transition diagrams. Then use case diagram is define actors that are acting and how the system is acting, that is use case. So these four diagrams should be there: data flow, data modeling, and state transition and use case diagrams. Then iTest, one requirement fully specified. So iTest is an online platform. It SRS organized extensively on system features rather than a flat list. Each feature gets its own discussion priority test links. So we'll learn that test. So requirement execute iTest client is that the student launches the client and the startup screen appears at low priority with no precondition. The requirement explicitly declares what is includes, extends, connect to, and is connected by flow traceability in a few lines. Okay. Then requirement engineering is still evolving. This is always involving. This is a part where it's always. This is for people who want to do some research work in software engineering if you are interested or not. So agile and user stories, model-based platform. These are the things that are research is going on. Then where AI is reshaping requirements work is drafting assistant. LLM is helping in assistant so that yes, humans sometimes will make some mistakes. LLM will help us to make it fast because this is very time consuming. And consistency, ambiguity check. It helps in keeping the file consistent, and also ambiguity. It helps to check the grammar, that is it not meaning something else. It's clearly mentioning what is meant to be. Then traceability mining. AI can help link requirements to code and test cases retroactively in legacy projects. Legacy projects means old projects. Okay, that are like from like they are like 20 years, 30 years, or 10 years old.